Welcome to an introduction to Amazon machine learning, which is a specific technology that Amazon provides. It is an on-demand hosted solution, so you do not have to run any infrastructure to use Amazon machine learning. It focuses on supervised learning, where you have data that has answers and you want to make predictions against that data. The focus with AML is on structured text data. And finally, we're going to build a complete system and be able to make predictions against that model. This course is for developers seeking an easy introduction to machine learning. Amazon Machine Learning gives you specific solutions that work across a broad range of domains, but is not a multi-algorithm machine learning system. So some of the paralysis of choice that you may have been confronted with when you first thought, hey, I need to start learning something about machine learning is not going to be present because Amazon Machine Learning has limited tweakability. It is also a great course for data scientists that know that Amazon Machine Learning is a fit for their problem space, that they can use stochastic gradient descent to solve their problem. It also has the benefits of being a hosted solution. So again, no infrastructure to run. And if your data is already in AWS, all the better. If you're a technical marketer with some expertise with AWS, you can also benefit from this course. AML is not a multi-algorithm all-purpose solution. So if you're an advanced data scientist with high demands and you really want to exert control over every aspect of your model, Amazon Machine Learning might not be a great fit for you. Not a lot of prerequisites for the course. You need an AWS account, which you can sign up for free. You will pay some amount of money when you run through these exercises. It's going to be on the order of $1, depending on how many times you try to create models. You need some basic experience with core AWS services. I'm not going to walk you through how to upload a file to S3, for example, or what the various attributes of a object in S3 are. It's also helpful if you have some kind of understanding of Python. We will use that to automate some of our system. It's important to note that no machine learning experience is needed. I assume nothing around your ability to understand machine learning. We define all our terms. When you are done with this course, you will be able to navigate the Amazon Machine Learning console and take a data set that is raw textual data and build an entire AML system that can make predictions. You'll be able to make predictions and understand when you would choose one versus another. You'll have some understanding about model accuracy. Unfortunately, part of data science is building enough models that you get a sense for model accuracy, but we definitely talk about the tools that AML provides in order to evaluate model accuracy. You'll also have an understanding of the operational concerns around running a real AML system. AML is not appropriate for everybody, and we'll talk about when AML is appropriate and when another solution might be a better fit. We talk about machine learning, and we also give an overview of Amazon machine learning. We create an AML system from scratch. Again, we take raw data from an open source data repository, and we take that all the way through all the different entities in an AML system and make predictions against the model that we're going to build. We cover some advanced concepts around tagging and model lifecycle. We cover alternatives to AML and limits of Amazon machine learning. It's important to note if you're not a developer, but you're, say, a technical marketer, we do primarily interact with Amazon machine learning via the AWS console. As I mentioned, there'll be some Python that really is around automation, and a full understanding of Python is definitely not required to get value out of this course. So what is machine learning? Machine learning at its essence is simply using an algorithm to find patterns in data. Typically, the process works like this. You're going to gather and prepare your data for the algorithm. You're going to run that algorithm and create something that's called a model, which is just a representation of the algorithm and the pattern that it has found in the data that you've given to it. And then you're going to review and refine the model by feeding it additional data and seeing how it compares with what you expect to happen. Finally, you will use the model by handing it data that it has not seen before and then getting some kind of result out of the system. So what kinds of data can you process? There are very many kinds of data that can be processed with machine learning. Images are one kind of data you can process. So you can train a machine learning model to determine if a given photo is an animal or a human being. You can also use machine learning to process audio input. If you've ever used Alexa or Siri, you have used machine learning with audio input. You can also process videos with machine learning, and sometimes those videos are split up into images, and then you use the same algorithms you would use with image processing. You can also use unstructured text as an input to a machine learning algorithm. And if you've used a search engine like Google, you have also used machine learning. Finally, you can use structured data as the foundation for your model, whether that's in comma-separated variable format or some other structured format such as JSON. There are two main kinds of machine learning. The first is unsupervised learning. In this case, you are providing data to an algorithm, but you're not providing any direction. The algorithm itself can examine the data and look for patterns in that data. In this example here, we have a graph where an algorithm has found 3 different clusters of records that are substantially the same. Supervised learning is slightly different. With supervised learning, part of the process is providing training data, which says, for these observations, this is the output I would expect. So, for example, you may have a collection of photos that have all been tagged with either the puppy or this is a kitten. And you can use this data to train a model so that if you present that model with a different photo of a puppy or a kitten that it has never seen before, it will predict, yes, this looks like a kitten, or yes, this looks like a puppy. When you're doing supervised learning, which is the focus of this course because that is what Amazon Machine Learning supports, there are a couple of things you want to be aware of to try to avoid. The first is called overfitting, and this occurs when you contort your model so that it matches 100% of the training data you provide. And the reason you want to avoid that is because when you force that, your model is unlikely to be any good at predicting data that it hasn't seen before because it will be so focused on the data that it has seen. You also want to avoid something called the curse of dimensionality, and this occurs when you have not enough data for the number of variables you have. So you may have 1,000 different variables that all lead up to one target variable, and you may not have enough data. The cure for that is to get more data or to drop variables that are uncorrelated with your target variable. Bad data is another possible concern. You want to make sure that red dot that is in this graph is valid data. It could be an outlier, or it could be just a typo or a bad sensor. And you need to understand your domain well enough to know when you can drop off points that are out of the norm and when they are important to include in your model. Because of the last 3 common issues, often machine learning is used to augment human decision making. So you will use the machine learning to come up with a set of probabilities, and if those probabilities for determining a picture is a puppy or a kitten are very high, then you let the machine make that determination. If the probability is 50-50 or 60-40, the machine did not do a very good job of pattern matching against that particular image, and then you can flag that and have a human being review it. Having both human beings and machine learning model work in concert can be a very powerful partnership. The reason why machine learning is interesting at all is because of the scale that it allows you to make decisions and find patterns and make predictions at. You can have tremendous scale in terms of data. You can feed a given system more data than any human being could consume in a lifetime. You can also have tremendous scale in terms of the number of variables. If you have enough training data for supervised learning, you can have tremendous number of variables, and therefore you can discern patterns in systems that a human being may not ever have found. And then finally, servers and computers are very much faster at executing certain kinds of algorithms than human beings are. And so with machine learning, you can get tremendous scale in terms of data, in terms of the number of variables that can play into that data and that can be teased out as being important from that data. And then also tremendous speed in terms of making decisions based on observations. So, what is Amazon machine learning and how does it differ from the wider world of machine learning in general? So, Amazon machine learning supports a subset of the functionality of general machine learning algorithms. It supports supervised learning, which means you're going to provide a set of observations with a target variable, and then you're going to later provide another set of observations, and Amazon machine learning is going to predict that variable. There are 3 different prediction types based on what the data type of that target variable is. Binary classification determines whether the target variable is true or false. An example would be, is this user going to buy my product or are they not going to? Multi-class classification is when the target variable is one of a known set of values. So an example of that would be, is this user inclined to purchase one of 5 or 10 different products? Which product are they most likely to want to purchase? Finally, you can also do regression with Amazon machine learning. And this is where the target value is a real number. And an example of that would be if we're calculating the sales price of an automobile or a home based on previous sales data. Amazon machine learning supports one algorithm, which is stochastic gradient descent. So what exactly does Amazon machine learning do for you? First of all, an interface to your data. Your data is primarily going to be on S3, although you can pull data from other data sources like Redshift and RDS. However, in those latter cases, your data will still be staged to S3. When you have your data on S3, you need to tell Amazon machine learning what your data looks like. What are the data types for each of the variables? Do they have names, or are they just all variable 1, variable 2, variable 3? Importantly, what is the target value? Which variable are you trying to predict? Amazon machine learning will also provide analysis of your data. This will include things like the number of missing values and any correlations between different variables. This will allow you to explore your data and understand if there are variables that you can drop from your model building process, or if there are variables that are very highly correlated to your target variable. Amazon machine learning bundles all of these things together, the schema, the location on S3, any other configuration information to get that data, and the analysis, and it's all called a data source. Amazon machine learning provides the server and the software to build a model. This is also called training a model. In addition, it also holds aside a portion of your original data source, which remember has both observations and real-world results in it to evaluate the model that is built. You can hold aside 30% or 40% or 10%, whatever you choose. And then those other observations are used to evaluate the efficacy of the model against real-world results. That's very, very important to do, and Amazon machine learning makes it trivial to do so. There are a couple of different ways to access the model, either asynchronously or synchronously. But the whole point of building a model and using Amazon machine learning is to be able to generate predictions from observations that are coming in from the real world that we do not have the answer for. And so you can control access to that model in terms of who can get access to those predictions in a very fine-grained manner. There are 2 main ways of interacting with Amazon machine learning. First is using the API, and it's important to know that the API is a first-class citizen. There are things you can do in the API that you cannot do in any other way. An example of that would be to create a data source from a MySQL RDS database. The other primary way you can interact with Amazon machine learning is via the AWS console. And because this is an introductory course, this will be the primary focus of our interaction with AML. The console provides a very powerful set of defaults, including defaults around the schema of a data source and the various settings that you can use to build your model. For first-time users of machine learning or Amazon machine learning, the defaults are more than adequate for building models that have accurate results. Amazon machine learning is available in 2 different regions, in the Northern Virginia region and in the Ireland region. Your data, however, can reside in any S3 or RDS or Redshift repository. However, if your data is in S3 in a different region, be aware of the S3 transfer costs that will be incurred by pulling data from one region to another region. As far as support, you have a couple of options. There is a Amazon machine learning blog that has some interesting posts. The forums are very active, not just with other AML users, but also with AWS staff. In my experience, it's very uncommon for you to post a question to the Amazon machine learning forums and not get an answer back within 1 business day from an AWS employee. And then obviously, if you have a Amazon support contract, you can reach out to them for support as well. Amazon machine learning has a couple of different ways of charging you. The first is when you're building a model or a data source, you pay by the compute hour to process the data. Obviously, the more data you have to process, the more expensive that is going to be. The second way that you're charged is when you're actually using the model. Depending on how you use the model, you'll pay about a penny for every 100 predictions. And if you want to be able to make synchronous predictions, you're going to pay an hourly rate for the server that is responding to those prediction requests. Now you know a bit more about what Amazon machine learning can do for you. So I'm going to introduce you to some terms that we're going to use as we build up a Amazon machine learning system. Obviously, data is at the core of any machine learning system. And I have downloaded some data from a machine learning repository out there on the internet. And the data files that we're going to examine and the URL from which I downloaded them are all available in your working files for this section. This data set is derived from census data. This is comma separate variable data. However, not all data that you pull from the site will be. And you can see that we have various different bits of information. We have what looks like numbers. We have some strings. Each of these is called a feature of our data. It's also called an attribute or a variable at different times. Each of these variables has a data type, and the one at the very end, in this case, turns out to be our target variable. A target variable is the variable that you're trying to predict. So in this particular case, we're trying to predict whether or not all of these other attributes will indicate to our system whether or not someone makes more or less than $50,000 a year. We also, in this data set, have an additional file, and this contains information like where the data came from, who's worked with the data. We're really interested in what's at the bottom, which happens to be a description of each variable. Does it have a fixed set of values like sex? Sex is either male or female in our data set. And so this helps us in a couple of ways. It helps us understand the data a little bit more, and then it also helps us because we can refer to our variables by the logical names that are provided here. We're going to have to write some software to combine this header file with our data file, but it's always better to use real names rather than variable 1, variable 2, variable 3 to refer to your variables, because we make reference to variables in other parts of the AML system, and it simply just makes the code more maintainable and more self-documented if you have a human readable name. Amazon machine learning doesn't care. Finally, each of these rows in this data file is called a record or an observation. In this case, this data set is called in totality training data. And the reason why it's training data is because this is data that has observations that include target variables. Each of these rows tells us someone who has never been married, someone who is not a family, someone who's white, someone who is 39 years old. Amazon machine learning is going to discern a pattern based on all the variables except for the target variable to see if they can predict the value of the target variable. And then later, we're going to pass in observations that contain everything except for the target variable and get back Amazon Machine Learning's best guess on what the target variable's given value is. So these are some common concepts around data in an Amazon Machine Learning system. The primary way in which you're going to interact with Amazon Machine Learning in this course is via the AWS console. When you select Amazon Machine Learning from the services after having logged in, you are presented with the dashboard. And this is basically your central place to go for all of your Amazon Machine Learning models and jobs and other pieces of your system. We can filter by the different types of objects, and we're going to discuss data sources, machine learning models, evaluations, and batch predictions in this section. The data that we have gathered and that we examined in the Amazon Machine Learning Concepts section needs to be turned into something that Amazon Machine Learning can use, and that's called a data source. And data sources have information like time when they were created, how long it took to process them, their status, a user-readable name that we can set and change. They also have information about what the target type of this particular data source was. If it is training data, you can also have data sources that are used just for prediction. And then we have other information like where the data lives on S3, the number of files that were processed, and the total size of the data files that Amazon Machine Learning processed. The end goal of Amazon Machine Learning is to build a model that we can make predictions against. So obviously the model is a key piece of the Amazon Machine Learning system. Again, with a model, we have information like the name of the model, the type of model that we built, and that depends on the type of the target variable. If our target variable is a Boolean value, then we're going to be doing binary classification. If it is a number, then we're going to be doing regression. And if it is a categorical value, one that has n different discrete values, then that is going to be multi-class classification. We see information like the completion time, the status of this model, and that obviously will change. This model is one that I created a little while ago, and so it is completed. We also see which data source we use to train this model. We also see any evaluations that we ran against a model. So an evaluation is basically where you hold back some of the training data and then you run the model against the observations of that data set and compare the predicted value that the model produces with the target variable that is the real world value from that data. And that gives us a way to evaluate the accuracy of a given model so that if you tweak a setting on a model or you tweak the data that you're passing to that model, you can compare those accuracy settings. We have some other model settings. These are values that are set at model build time. Once they're set and your model is created, you cannot change these values. And these are things such as maximum size of the model, the number of passes that you want your algorithm to go through, whether or not your data was randomized before Amazon Machine Learning touched it, or whether it needs to be randomized by the AML process. And regularization type is a parameter that you can tweak. Amazon Machine Learning sets it to a value that tends to be good for most systems. What the regularization type does is it helps control the weights of the features that feed into your model so as to either push to zero weights that would otherwise be very, very small, or to stabilize weights when there is high correlation between two different variables. The other important setting that you're going to set up before you create a model is the recipe. And the recipe lets you transform your data between where it lies on S3 or any other data source and when the model sees it. This allows you to drop columns or transform columns without touching your source data. Obviously, in this course, we have access to source data. We can transform it before we ever upload it to S3, but there are often situations where you have access to data that you can read, but you can't really rearrange that data. And so recipes are the way that you rearrange data without touching the source data before the model gets built. Obviously, we want to be able to make predictions against this model. We can make multiple different kinds of predictions. I'm going to show you a real-time prediction, which is just one record. You can also do batch predictions, which are multiple records. So in this case, I have just taken an observation from our data set. This observation does not include the target variable. And you can see that Amazon Machine Learning has placed the values for each of the features in their corresponding section. And this is, again, a case where you want to make sure that you have valid header lines, because it's a lot easier to remember that work class should be something like local-gov than to remember that var2 should be that. We then create a prediction and we get these results back. And so this tells us a number of things. The algorithm that we used for this model, the model prediction type. So again, that's binary or regression. And then we have the label that we are going to get. And so that is either a 1 or a 0 for a binary classification system. And then we have a confidence score. The higher that confidence score is, the more likely statistically the model has calculated the value to be what it says. So these are some concepts around the console in a Amazon machine learning system. When you are using Amazon machine learning, it is important to limit access to your models, your data sources, and the other artifacts of your system. Amazon's method for doing so is identity and access management. To illustrate how you can use IAM to control access to your AML resources, I've created two different accounts. The first is an admin account, which will be able to create models, create data sources. Let's look at the permission of this admin account. So this user has two policies that are attached to them. The first is a canned Amazon managed policy, which gives full access to the Amazon Machine Learning API. So this user can do anything via the AML API. They can create data sources, they can delete data sources, they can create models, they can create batch predictions. And the nice thing about using the CAN policy is if Amazon adds a new AML feature, that will be automatically added to the AML policy that is managed by Amazon. The second policy gives us access to read and write from one S3 bucket that we're going to use to store our data. The second user is much more limited, and they are going to be able to create predictions, and that's about it. They have, again, two canned policies that are Amazon managed. The first lets them create batch predictions, and the second lets them create real-time predictions. We also have a few other customer managed policies, and these are policies that I've created. The first is describe AML models, and the reason for including that policy is because for this user to create any predictions, they need to have model ID. And it's much easier to look up a model ID by model name than it is to hard code a model ID. And so that policy just lets them look at all the AML models and find the model ID. The second custom policy is one that lets them create data sources from S3. And the reason you want to be able to do that is if you want to create any batch predictions, you're going to want to upload the data, then be able to create a data source, and then from there you'll create a batch prediction. The final one is a policy that lets them have access to a certain prefix in an S3 bucket. They can both read and write from that prefix. And the reason for that is, again, for batch predictions, you need to be able to read and write from S3. Write in order to put your observations up, and read in order to read the batch predictions. There is also a bucket policy that is important. And this is something that if you use the machine learning console to create data sources or predictions, the console will take care of for you. But if you are using the API, you need to make sure that you allow the Amazon machine learning service to have access to your bucket. All of these policies are available in the working files for this section. Last thing to note is that for production, you may have far more granular permissions. You may have one user that is responsible for putting the data on S3. You may have another user that's responsible for creating the models. You may have a third user that is responsible for only real-time predictions. You can make the permissions as granular as you'd like them to be. So where can the data that is the foundation of your Amazon machine learning model reside? If you're using the console, you have two different choices. You can use Amazon S3, in which case you need to make sure that you have permission to read the data from the location that you provide. You can also use Redshift. If you use Redshift, you need to provide information on how to get access to your data, as well as the SQL query you're going to run against your data to provide the data that you're going to build your model upon. It's important to realize a limitation of Redshift is that the cluster must reside in the same region as the Amazon machine learning data source and the S3 bucket that your Redshift data is going to be staged to. That pretty much limits you to either a Redshift cluster in Northern Virginia or a Redshift cluster in Dublin. There's a third option that you can use to create a data source. That is a MySQL RDS instance. That is not available via the console. It's only available via the API. Both the Redshift and the RDS instance let you quickly build a data source based on a query against the database. But in the end, the data is still staged to Amazon S3. That points out a fourth option, which you can use to pull data from any data source on-prem or within AWS. That would be a tool that can read from wherever your data is stored and output to S3. There are several tools like these. They're often called ETL tools. Some common ones are Pentaho Kettle or Informatica. They can take data from on-prem data sources or other RDS instances or databases running on EC2 instances and output them to S3. There's also an AWS native ETL tool called Data Pipeline, and I've provided a link to a data pipeline tutorial and a couple of ETL tools in the working files. So essentially, your data will always live on S3, although you have some options on how to get it to S3. Amazon machine learning requires data sources to map between the data that we have and the algorithm that Amazon machine learning is going to run against that data. We're going to process the data, we're going to upload it to S3, and then we're going to create a data source. In this directory, I have some data I downloaded. It's from the data source that we explored in the Amazon Machine Learning Concepts data section. And I also have a Python script that I have written. So the Python script does some pretty simple preprocessing. On lines 31 through 33, we're splitting this data source up into 3 different files. And the reason for that is because this is a mock data source. It's real data, but it's not a real world situation where I'm getting continuous streams of data coming in. So in order to complete this lesson, I'm going to divide this one data source up into an initial training data set, a secondary training data set, and a data set that will not have the target value that I can use for batch processing. The other thing I do of note in here is I make sure that I'm writing a header line to every file so that they all have the same headers. And I also convert on lines 45 and 46 the value that is in the data file to a false or true value, because the value in the data file is what you can see on lines 39 and 40, less than or equal to $50,000 or greater than $50,000. And Amazon Machine Learning can't handle that. So it's a fairly simple script, and it will be available in the working files of this section. You can see the data looks the same as it did when we looked at it in the Amazon Machine Learning Concepts data section. The next thing we're going to do is create a location on S3 for this data to reside. So we're going to create a folder in a bucket that I've previously created. And then we're simply going to run the Python script. And we can see that we have 3 different files there. One is for initial training, one is for subsequent training, and one is for batch process. So we're going to upload the file via the management console. You can certainly do the same thing via the command line. At this time, we're simply going to upload the initial training file. Don't need to do anything special with permissions at this point, or encryption or storage class. We upload the file. Now we're going to create a data source. So we're going to pick from the S3 location because this is not a Redshift data source. And we pick our training data set. One thing that's important to note is that when you're accessing a prefix for the first time, there's a certain permission that needs to be applied to it. The console takes care of adding that permission. This data is now readable by Amazon Machine Learning, and we are going to use an auto-generated schema. We will, however, have a chance to modify the schema. Important things to note: the first line does include a set of headers, and that is going to make it easier for us to debug this model to send real-time requests in a coherent manner. So if you have the option to use a header, always do so. The next thing to do is to review our fields, and you can see we have the names, we have a data type, and that is something that we can change. And we also have sample fill values. For instance, you may have age not be a numeric value. It's not a continuous value. It could be categorical. However, Amazon Machine Learning is pretty good about guessing these things. After a quick scan, I can see that these are all correct. The next thing to do is determine whether or not this is a data source we're going to be using for training or for a batch prediction. If you're using a data source for training, you need to provide a target value. In this case, it is the income greater than $50,000, which again, remember, we translated from a string to a binary value in the processing script. It's going to ask us if we have a row identifier. Again, this is useful for debugging purposes. If you have a row identifier, it is going to be excluded from your model creation. So if there is useful information in a row identifier, you may want to double that and have it be an extra column so that you can have one column be a row identifier and the other be used by the model building process. We don't have a row identifier in this situation, so we can review our data source settings and we can create the data source. The status will remain in pending until the data source is available to be used. Data sources are the foundation of Amazon Machine Learning. Let's look at the data source we created in the loading data chapter. When we look at the summary, we see information like the ID of the data source. And since we created this via the console, it's going to be automatically assigned. We have a name that we can edit. We have the time it was created. We have a completion time and a compute time. And the completion time is the calendar time that it took from when we requested this data source to be created to when it was finished. The compute time is going to be larger than that because there may have been more than one virtual server working to process this data. We have a status value and we have a schema. We created the schema by going through the steps in the data source wizard. So we selected things like what our row identifier was going to be and what our target attribute was, and also all of the attribute names and the data types for each attribute. One thing that's worth noting about the schema is that you can exclude attributes from being considered by the model at the schema level. Another thing worth noting is that you can save off this file and put it on a location in S3, and you can reference it from other data source creation calls. If you're going to be using the API to create a large number of data sources, especially for a large number of batch predictions, you're probably going to want to do that. You can also turn this into a string and pass it in when you're creating the data source via an API. I would recommend creating the schema once via the management console and then leveraging the file that was created, although of course you could create this programmatically if you wanted to. We also have a log file. This log file is not very interesting, but if you had an error in your data source creation, you would go to this log file to see if there were any obvious issues that you could resolve around permissions or whatnot. And if you need to open a ticket with Amazon support, they are probably going to want the contents of this log file. We see other information in the summary, the target distribution, our location on S3, the number of files, how many records were seen, the attribute breakdown in terms of the number of attributes and the type of those attributes. And then we also have the ability to add tags to this data source. And if we add a tag, like author is Dan, then any models that we create from this data source will be tagged with that same tag. The tags basically propagate to all the downstream artifacts, and any batch predictions that we make from a model that was built from this data source will also have that tag. So you could see how that would be very useful in terms of organizing a large number of models. In this particular situation, if you had more than one author and they were all in the same account, it might be useful to have the different models and the different data sources tagged with the different authors. You also can see more detail about the target distribution. In this case, we can see that we have about 4 times as many incomes less than $50,000 a year than we do incomes greater than $50,000 a year. It's important to know the distribution of the target attribute is somewhat even. For example, to take it to an absurd length, if we had exactly one value that had an income greater than $50,000 and all the rest of the values had less than, the features that went into that particular observation, that single observation, would be weighted very, very highly when it came to predicting whether or not someone had an income of greater than $50,000 or less. That obviously doesn't really correlate with the real world. There are a lot of factors that go into that income prediction. And so it wouldn't be very accurate at predicting, which is the whole point of Amazon machine learning. If you look at your target distribution and you see a large number of values for all of your target values, or in the case of a numeric target value, a nice looking curve, your data is probably going to lead to good predictions. If you don't, then you may want to revisit your data. And that's what this whole section is about in terms of looking at your data source. It lets you explore your data. It lets you know if you need to gather more data or different kinds of data or different attributes on the same data. If you have any missing values, they will appear here. If you are missing a target value from a row in your data, that is going to be a discarded row. So that row will not be used to train your model. If you have missing values for numeric attributes, then those will be tagged as missing, and that will let Amazon machine learning learn from missing values. We also see a list of the 4 different categories of attributes, and binary attributes can have the following values: either a 1 or a T or a true or a Y or a yes. So one of those 5 values. Booleans can have either true or false values. If the value is a 1 or a T or a true or a Y or a yes, that is a true value. If it is a 0 or an F or a false or an N or a no, that is a false value. Categorical attributes have a certain number of values. So the value of the attribute is always going to be one of n distinct values. The days of the week are a perfect example. In the Gregorian calendar, there will always be one of 7 values for the day of the week. Numeric attributes can have any continuous numeric value in it. An example that might be a Unix timestamp, measuring the number of seconds or milliseconds since 1970. Text values are the other data type, and anything that doesn't fit into one of the previous 3 data types is going to be categorized as a text data type. That includes structured data like dates. So if you look at a given data type, you can see the attributes that have that data type, and you can see interesting information about each of these attributes, including the correlation to the target, the number of the unique values in the case of categorical attributes. frequent and less frequent values. And then you can also see a histogram of the values for a given attribute. You can even see sample data. So again, this lets you explore relations within your data in the Amazon Machine Learning interface. And now you can look at an Amazon Machine Learning data source and understand the underlying data better. There are a few other considerations around your data and your data sources you might want to consider. You might want to think about how much data you are planning to use when you build an Amazon machine learning model. The obvious answer is as much data as you can get. More data is better, especially more observations, as opposed to more attributes. You do want to avoid too many features. You can try to build a model with tens or hundreds of observations. That may or may not work depending on the granularity of your data. This is a good place for you to experiment and see. You also want to think about protecting your data. In the AML and IM chapter, we talked about setting up different IM roles. You can do this to a very fine level of granularity. For instance, you could create an IM role that would only create data sources. In the AML and IM chapter, we talked about setting up IM users and permissions to protect your data. You can do that at a very fine level of granularity. For example, you could have an IM user that is only allowed to read data from S3 and create data sources, and no other user is allowed to create data sources. You can also turn on server-side encryption, and this is a standard S3 feature. You can also remove access to your data after you create your model. You can remove the IM permissions from your users after they have created data sources and models. You can also go so far as to delete your data source. If you do delete your data source, your model will continue to work, but you will not be able to test drive real-time predictions. You can still create an endpoint and use real-time predictions. You just can't test drive real-time predictions, and your evaluations may not function correctly. So deleting your data source is kind of a radical step, but if you have certain compliance needs, you may need to take that step. Finally, you want to think about how to prepare your data before it gets up to S3 or before it gets to an S3 location that you're going to make a data source out of. You can anonymize your data, so you can remove any PII. You can take out unneeded fields to reduce storage costs. You can convert data types. We saw that with the income greater than or less than $50,000 in the load your data section. And then you can standardize your data. You can do some standardization of data when your model is being built using something called a recipe. But if you need to convert, say, an abbreviation to a full word, or to convert days of the week that are sometimes abbreviated, sometimes spelled out fully, all to the same format, you're probably going to want to do that before it gets up into S3. These are some final items to consider regarding your data. Now we're ready to build a model, which puts us one step closer to being able to make predictions. The easiest way to do that is to go to your data source summary page. And this is the data source that we built in the loading your data section. Go to the use this data source button and choose create a ML model. At this screen, you can change your model name. You can choose between two sets of settings. The first is the default setting, and the second is a custom setting. The default setting is a great way to get started. It makes a lot of choices for you that Amazon Machine Learning has seen work across a wide variety of domains and settings and data. But of course, you can always choose the custom option. You can choose an evaluation name, and you can review your model. So we have our data, we have the model settings, we have a recipe, we have the advanced settings. We also can see that the tags have been propagated from the data source, and I can choose to create a model. We're going to go through the actual custom process. So you can go back and choose the custom settings, and this is going to let us configure the model build as much as Amazon Machine Learning lets you do that. So we have a recipe, and we can change the recipe here. The recipe is a way for you to make modifications to your data between when the data is loaded from the data source and when the model is built. For example, if I knew I wanted to omit the age variable from the model, I could delete it from this recipe, and then it would no longer be seen by the model. From here, I can either make modifications or I can reload the default that has been provided by Amazon Machine Learning based on its analysis of our data. I can also review my data, at least a subset of my data, so I can get some idea of what the various fields relate to. That doesn't matter very much if you have intelligent names on your fields, but if you don't, it may be very helpful to see the values of the data when you're trying to create a recipe. We continue on to some other settings. Maximum model size, that affects how much a real-time endpoint costs and also the complexity of the model. The number of data passes affects, again, the pattern finding of your model. The fewer passes the algorithm makes, the more coarse-grained your model is going to be, but the quicker it will be to build that model. If you have already randomized your data, for instance, if you're pulling your data from a SQL database and you ordered it by a random number, you can not shuffle your data, and that will slightly speed up your model building process. You can also tweak the regularization settings, and the regularization settings stabilize feature weights. This is something that you can experiment with. For your first model creation, I would definitely choose the default values that Amazon Machine Learning has provided. You can even turn off regularization if you want to experiment and see how that affects your results. Finally, you can create an evaluation of your model. And this is where we compare model predictions against real world values. So you can decide not to evaluate the model at the current time, or you can evaluate the model based on a subset of the data source that you're using to train the model. And if you're doing that, you can choose either a sequential set or a random subset, or you can use an entirely different data source for your model evaluation. Then you can review your model settings. This screen should look somewhat familiar. The difference is, since we used custom settings, we can now change the custom settings. We can see the recipe that we are going to use. We can see the advanced settings that we chose to go with, and then you create your machine learning model. This is going to take a period of time. Don't expect it to be available right away, but now you've created an Amazon machine learning model. We've already seen a default recipe in the initial model build chapter, and the default recipe is a great place to start. However, we're going to take a deeper look at recipes and how you can modify your data to build models that are more accurate. So we're starting out with an existing data source, the same data source we loaded in the loading your data chapter. We're going to call this a tweaked recipe. And whenever you are changing a recipe, you need to use the custom training and evaluation settings. So here's our default recipe. The three important pieces of any recipe are the groups section, the assignment section, and the output section. The groups section allows you to group similar variables together so that you can apply transformations on those variables all at the same time. You can also create groups that exclude other variables. So if there was a variable that you did not want to include when you're doing model exploration, you can absolutely just remove that variable from the group. There are 5 groups by default that are created for you. There's one called all inputs, which is all the input variables. And then there's one for each data type. All numeric, which you see right there, all categorical, all text, and all binary. By using the group remove function, I am creating a set of variables that excludes the FNL weight variable. Assignments let you create intermediate variables that you can use elsewhere in your recipe. And that can be great for creating self-documenting code, or if you have one variable that you want to use in 2 different ways. You may want to use the capital gains variable in a normalized fashion and also in a non-normalized fashion or a binned fashion. And then finally, the outputs section is what your model is actually going to see. So if something is not listed there, your model is not going to see it and be able to take advantage of it. So as far as the actual transformations that you can do in a recipe for text variable types, you can change the tokenization. By default, every string of text is broken up on white space, but you can use the ngram or the OSB transformations to tokenize things in a different manner. You can also transform text. You can lowercase it and you can remove punctuation. For numbers, you have two different transformations. You can bin the numbers, as we've done here, and that basically is turning a continuous numeric variable into a categorical variable based on however many bins you specify. And you can specify between 5 and 1,000 bins. And you can also normalize a numeric variable. And that takes a variable that may range from 0 to 10 million and normalizes it down to between 0 and 1. And that's great when you have a large range differential, as we did with capital gains. Finally, for categorical or text values, you can do a Cartesian join, which captures the interactions between two variables as another variable. So we're going to verify our recipe to make sure it works, and it has to be valid JSON. And we're not going to change any of the other settings. And we are going to create our model with a very tweaked recipe. So recipes are a major tool you can use to increase the accuracy of your model. Experimenting with different data transformations and different variables can increase the accuracy of your model. If you create a model using the default settings, you're going to have a certain part of your data held back for an evaluation. You can also create an evaluation against a model using an entirely different data source. For this model, which we created previously, we can look at the evaluation. So we see normal information like the ID of the data source that was used to create this model and how long it took to complete, and the log file, which again, we probably won't need to look at unless there's some issue with our evaluation. The model performance metric is the most important piece on this page. And this performance metric is going to vary for the data type of your target variable. What we're looking at here is a binary classification system. If you recall, we're trying to predict whether or not, given a set of observations, someone has an income greater than $50,000 a year or less than $50,000 a year, which is a binary decision. So for binary classification systems, the performance metric is the AUC, which stands for area under the curve. What we have right here is a pretty good AUC. The closer to 1 your AUC is, the better. The closer to 0 it is, the more your model is living in a mirror world where it thinks true is false and false is true. The closer to 0.5 your AUC is, the more likely it is that your model is useless and can't have any predictive power whatsoever. So a baseline AUC is not very good. The next thing we can look at is evaluation alerts. And these are a set of checks that Amazon Machine Learning provides for you, guidelines to ensure that your evaluation is actually useful. So it checks things like, is your evaluation done on different data than the training data? Because if you're just reusing your training data, it's not going to be very effective. Are you using enough data? If you have 10 million records of training data and you're doing an evaluation on 10 of those, again, that's not going to be a very useful evaluation. Does the schema match between the training data and the evaluation data? And then finally, is the distribution of the target value, the value that we're trying to predict, similar between the training data and the evaluation data? If they're vastly different, again, the evaluation may not be a valid one. Finally, you can do some detailed exploration of your evaluation. It's worth noting again that this is going to be different for each different data type of your target attribute. For binary classification, you can see that we have a graph here where the gray area is true negatives, the yellow area is true positives, and then the areas that are gray or yellow that have slash red lines are the observations where the model got it wrong. So someone actually made over $50,000 a year, but we predicted that they made less, or vice versa. So we can control the point at which we're going to mark something as positive or negative. And you can do that by simply dragging this score threshold. And you can see as we drag it to the right that we have more and more false negatives, but fewer and fewer false positives. You might want to do that if the action you're planning to take is an expensive one. If we're planning to have a sales rep reach out and call each of these consumers based on their income, then we may want to have very few false positives where somebody actually had an income lower than our target value. If, on the other hand, we're doing something that is relatively cheap, then we may want to drag the scoring threshold over and have a large number of false positives but few false negatives. That would be an action like sending an email or something that's relatively low touch. Either way, you want to make sure that you save your score threshold. If you do not save your score threshold, then your predictions will still be based on that old scoring threshold of 0.5. You can see that we also have some advanced metrics, and these will change as I change that scoring threshold. And so this can give you some more information about the effects of that scoring threshold. Your false positive rate is basically the false alarm. How many actual negatives were predicted as positives? Precision is how many true positives were correctly marked as positive over how many observations were predicted as positive across the entire data set. Recall is the percent of positives that were correctly predicted, and accuracy is the fraction of correct predictions, whether positive or negative. So again, think about when you're adjusting your scoring threshold, do you need to be more concerned with false negatives or false positives? Finally, this evaluation screen, especially the Explore Performance section, will be different based on the data type of your target attribute. For instance, categories, instead of having this nice chart, have a confusion matrix, which basically gives you the false positive and false negative for each category. And then if your target variable type is numeric, you're going to see what's called a residual, which is the difference between the calculated value and the true value, and you want that centered. It's important to note that evaluations can be created by an API call. If you do so, you will have the key performance metric that was shown on the summary page, but you will not have access to the detailed scoring information and advanced metrics that were available in the console. Using evaluations correctly let you control and know the accuracy of your model. Once you've built your model, you're obviously going to want to make predictions against that model. That's the whole point of this exercise, to take data you've previously gathered and found patterns in, and then make predictions about observations. So when you've reached this point, you need to decide, am I going to use batch predictions or real-time predictions? They are similar in a number of ways. They both access the same underlying model. Therefore, they both need the same set of features in your observations. So every record you send to get a prediction against, you're going to need to provide the same features and the same number of variables that you provided in your training data, minus, of course, the target variable, which is what you're really trying to find. Access to both are also controlled by IAM, which is Amazon's service for controlling access to all of their APIs. So how do you decide between batch and real-time prediction? There are a number of things that can help you pick one or the other. The first is how many observations you have to process. Do you have one? Do you have 1,000 at a time? Do you have millions at a time? Obviously, the more you have, the more likely it is that batch prediction is going to be a better fit. How responsive do you need to be? If you're building something that's going to fit into a user interface, an admin portal or something like that, then you're probably going to lean towards real-time predictions, which return immediately. Batch processing does not have any guarantees on when you will get your predictions back. There is a slight pricing difference between the two models, and so if you're extremely price conscious, that might play a role as well. Batch processing allows you to process about 1 terabyte of data in a job, and that works out to about 100 million records. If you need to process more data than that, then you need to break that up into separate batch processing jobs. How it works is you create a data source, which is pulling from S3 or RDS or Redshift, that has all of the attributes of the training data minus the target variable. You then specify additional information, such as where you want the prediction file to be written out to on S3, and then you kick off a batch processing job. Now you can poll periodically for the status of that batch processing job. And when it's completed, you can go to that location on S3 that you provided and find your output file if it was a successful job. If it was a failed job, you need to look at the error message and see what the issue was. When it's a successful job, that results file will have one row of prediction for each row of the observations that you provided in the data source. What that actual prediction looks like depends on what kind of model you have, but they'll match up 1-to-1. As far as pricing, batch processing charges you a dime for every 1,000 records, rounded up. Therefore, batch processing one record costs the same as batch processing 1,000 records. When you want to use real-time processing, you follow a slightly different path. Create something called an endpoint. When you successfully create an endpoint, you will get back a return value that will include various things such as the URL that you will call to actually make predictions. And it will also include a number that is the number of requests per second that this endpoint can support. I've typically seen that number be 200 requests per second, but you need to check that. So to actually make a real-time prediction, you're going to call in with a observation that has the same number of variables as your training data, again, minus the target variable, and then you will get back a data structure that will include the prediction value. The pricing for real-time predictions is based on the number of requests you make, and it's about 1 penny per 100 requests. However, while you're running that real-time endpoint, you're also going to pay a capacity charge, which is based on the size of your model. So if your model requires 100 megabytes of memory, it's going to cost twice as much as if your model requires 50 megabytes of memory. It's important to realize that you can combine these two alternatives. So if you have one model and you build an application around that model, there may be times when you are making real-time calls into that model. There may be other times where batch processing is the better way to get predictions. So use the method of gaining access to your predictions that works best for your use case. If you have something that is primarily data focused with a large amount of observations, use batch processing. If you have a situation where you're building a user interface or you need immediate responses, then real-time processing is what you're going to want to use. Batch predictions let you process a large amount of data through your model, making thousands or millions of predictions. When you create a batch prediction, the result is going to be asynchronous. It's going to take a while to process the records and give you a result. We're going to walk through creating a batch prediction in the console. The first thing you want to do is upload your data or make your data available. Again, you can do it via S3 or Amazon RDS or Redshift, but we're going to do it via S3. So we're uploading a file. If you recall, in the loading your data section, there was a Python script which split some sample data out into 3 different data files. And we're going to use the adult to test CSV file, which is formatted for batch predictions. It does not have the target attribute. It still has a header row, and it has the same input variables as the training data we use to create the model. So we upload that. Then we can go to our model. The easiest way to create a batch prediction against the model is to go to the list of models and then simply create a batch prediction. As far as the input data for your batch prediction, you can pull from an existing data source, or you can create a new data source. So we're going to create a batch data source. So this data source will only be used for batch predictions, but you can run batch prediction from the data in this data source through multiple different models if you want to. So that is the file I just uploaded to S3. It does contain the column names. Amazon Machine Learning is going to verify that the schema matches. And then we need to have an output S3 location. And I'm going to pick this destination. There will be several subdirectories created underneath that. It's going to ask us to grant permission to the Amazon Machine Learning Service to this S3 location. If you are creating a batch prediction via the API, you need to make sure that you update your bucket policy to allow Amazon Machine Learning to write to whatever the output location is. You can see again that our tags have followed us along because we tagged the original data source and they were copied to the model, and now they're going to be copied to this batch prediction as well. So we're going to create a batch prediction. It's going to take a few minutes. As part of the working files for this section, I have created a Python script which does essentially what we just did. Again, the steps are you load your data, and with the API, you actually need to load a schema as well. And so what I did is I created a schema via the console, and then I just cut and paste it into a file, and then I'm going to upload that schema to S3 as well. And the only real difference between the schema of the batch prediction file and the schema of the training data is the target attribute name on line 5. That is going to be null for batch prediction data sources. So we upload the test data, we upload the schema, we create a data source, and again, we need to make sure that we pass in either the location of the schema on S3, or we can pass in the actual schema string if that's something you would choose to do. Since it's a batch prediction, we don't need to compute statistics for this data source, and that will save us a little bit of time. If you are creating a data source to train a model, then you do need to compute statistics. We're going to look up the model that we want to run this batch prediction through. Then on lines 43 through 48, we're actually creating the batch prediction. We get to set the ID to whatever we want. We have to pass in a model that we're running this data through, and we also have to provide an output URI on S3. On lines 55 and 56, we're using one of Boto's nice features. This is a waiter. This is going to pull the batch prediction that was created from this data source until it is done. So we don't have to write any polling logic. Then when we know that it's done, we're going to get the batch response again, and we want to eventually get to the file. That's the whole point of this, is to get to the file of predictions. So the proper way to do that is to look at the manifest. That is something that Amazon Machine Learning writes for you, and that has content like you can see on line 70. It's basically a map between the input location and an output file. So we just need to download the manifest file, load it up into memory, treat it as a JSON file, which we do on line 76. And then we want to grab the output file from the JSON manifest. And then that gives us a key into S3, into our bucket, and we can just download that file. We output the file name. It's going to be a gzip file, and we will see what that looks like. So this batch prediction is completed, and we can go look at S3. So here's our manifest. You would use the manifest if you wanted to automatically find the location of the results based on the input data, but we don't need to do that because we're navigating via the console. So you can see that it is a gzip file. We're going to download it. You can see that we're given a number of lines. Look at the top 10 lines. We're given a best answer and a score. The best answer is a 1 if the model predicts a true value and a 0 if it predicts a false. And then we have more information in the score, which is the actual number that the model came up with. If you remember when we looked at the evaluation section, the score threshold was the number that determines whether or not the best answer is a 0 or 1 based on the score. For categorical target variables or numeric target variables, the output of this file is going to be different, but it's always going to give you one line per one line of input. However, if the input observation is not valid, then the corresponding line on the output may be blank. Batch predictions allow you to make asynchronous use of your model to process large amounts of data. Real-time predictions let you get a single prediction from your model synchronously. Unlike batch predictions, where you have to wait for the model to run through your data and give you predictions and look up the results on S3, real-time predictions give you the answer that you're seeking right away. The first step to creating a real-time prediction from a model is to turn on the real-time endpoint. And the easiest way to do that is from the model section. You can choose the action to create the real-time endpoint. This gives us a warning, talks about the size of our model and the costs that we may possibly be incurring. Now we see that the real-time endpoint is being created. Real-time predictions are always going to be made via the API. So this script is part of your working files for this chapter. It's a simple Python script that calls into the real-time endpoint with one observation. So we look up the model ID on lines 5 through 7. On lines 9 through 10, we are taking that model ID and looking up the endpoint URL. Lines 13 through 19, we are building our input. And this is going to be the variable names that our model is expecting, and then the values of our observation. From there, we call out to Amazon Machine Learning, and you can see on line 29, some sample output includes information like which algorithm was used, the request ID, which is something you're going to need if you need to open a ticket with Amazon, the date that the request was made, the predicted score. So similar to the batch prediction, you're going to get a label or a best guess, and then you're going to get a score. Again, this output will change based on what type of target variable you are predicting, whether that's numeric or categorical or binary, as in the case here. But the most important thing and the data that you're probably going to make decisions on is the predicted label. And we're going to simply print that response. So let's check and see if the endpoint has been created. It is, because it says real-time predictions are now enabled. So let's actually run a real-time prediction. We need to authenticate to make a real-time prediction. This access key and secret access key are the values that we created when we created the IAM user that was for predictions only back in the AML and IAM chapter. A little bit underwhelming in terms of all the work that we went through to get to this point, but we're leveraging all of the data that we processed, the data sources we made, the model we created, the evaluation we did to get that number 1 or number 0 for a given observation in real time. You may want to turn off your real-time endpoint when you're done testing because you're going to be charged for every hour that that runs. Of course, if you turn off the real-time endpoint, if you have applications that are reaching out to that real-time endpoint, they will no longer be able to function. So in a production system, you're not going to do this. Real-time predictions are great for interactive applications where you might want to pass in one observation and get back a prediction in a synchronous fashion. So why would you manage your models and your AML process via the API? Aside from the obvious benefit of automating your interaction with Amazon Machine Learning, thereby leading to more consistency and reliability, there are some other benefits. The first is it makes it easy for you to update your model. And I put update in quotes because you're never really updating the model. You are simply training a new model based on a superset of the data, if you're bringing in new data, or tweaked parameters. So you still have to go through the whole training process. But if you drive everything off an API, it can be very easy to tweak one small parameter or to pull in a different data source and build that model, as opposed to going through all the steps in the management console. You also can compare model configurations and judge which model is going to be more effective in terms of producing the predictions that you need based on the evaluation data. So an example of that are these two model evaluation graphs, which are pulling from the same data source. They have a different recipe, and they have different properties. They have different numbers of false negatives and false positives. And the model on the left is far more noisy than the model on the right. You may care more about false negatives or false positives depending on your use case. If you are going to spend money, for example, you're going to have someone from a call center call all of the people that are marked as likely to buy your product, you're going to care more about having fewer false positives than you will false negatives. On the other hand, if you're simply driving some kind of automated near zero marginal cost process, then you may not care as much about a false positive. One final reason to automate your interactions with Amazon machine learning and model creation is because you can chain the output of models. So an example of that would be where you take the output from one model and have it be one of the data sources, possibly enriched, that is the input for another model. An example of that might be if you have a tremendously large data set, you might be able to look at your customers and find out which customers are likely to purchase something from you. You may want to take that subset of customers and possibly enrich it with more data and then find out which product each customer is likely to buy. These are some of the reasons to manage your model and AML interactions via the API. Managing via the API will let you create consistent replicable systems around your Amazon machine learning models. First thing to note is that you can create or delete any of the objects in an AML system, data sources, evaluations, etc., via the API. The second thing to note is that you can create the underlying infrastructure that your Amazon machine learning model will occupy via CloudFormation. You can create S3 buckets, bucket policies, IAM users, and the permissions that they need to execute against machine learning models, all via CloudFormation. Unfortunately, you cannot create machine learning artifacts directly in CloudFormation, only the underlying infrastructure. If you're building a production system, you'll want to monitor the usage of that system. CloudWatch is the way to do that. Managing via the API means that you may need more permissions. I actually had to add permissions to the AWS machine learning admin user to allow that user to see the CloudWatch metrics. And I also had to add a permission to the prediction user to allow them to look up models via tags. And we'll be seeing that in a little bit. Both of those JSON files are in the working files for this chapter. So you can look at various metrics for a given model, including how many batch predictions have happened, how many failures have happened, and how many real-time predictions have happened. So you can see all of these over a given period. Obviously, we are not seeing too much action on this graph at this time because this is a lesson. But if you're in a production system, knowing how many predictions are flowing through your machine learning models can be very helpful in determining if those models are being used or how much value they are providing. You can also leverage tags. And we already saw how you can use tags to track how authorship flows through a system, but you can also use them to set up environments. So you can imagine that you might have a model that is a version 1 model, and you have clients that are using that model, and then you are working on a version 2 model. You might be tweaking the recipe, you might be trying to gather more data, and you want to be able to transparently swap that model out when it's ready to go. Tags are one way to do that. So I'm going to add a tag of environment and a value. So I'm adding an environment tag, and I'm also going to add a timestamp tag. The environment tag is going to let me have clients look up a model to use via that tag so that I can swap it out. The prod timestamp is going to let me know which model was used to build downstream artifacts, whether that's batch predictions or evaluations. The value for the timestamp is less important, but you just need to make sure it's something that is identifiable and consistent. So we've added these tags to this model. Now we're going to run a real-time prediction against this model, looking it up via the tag as opposed to via the model name, which is what we were doing before. This file does real-time prediction, but instead of looking up the model by the model name, which we were doing in the more on real-time predictions code, we are looking at via tags, which is far more flexible because tags can be applied to different models at different times. So most of the code is exactly the same. The key differences are lines 5 through 21, which is how we find the model ID and the endpoint URL that we're going to send the request to. You can see on line 6, we actually look up all of the binary classification models, and then we iterate over them on lines 11 through 17, looking to see if we have a tag that matches ENVT as the key and prod-income as the value. If we do find that, then we return that model ID and we continue on our merry way. Let's make sure this works. So again, we get the same value back, which makes sense because we're running against the same model and we pass in the same data, but we looked it up via an entirely different path. So some of the limits of managing via the API are you can only filter by certain criteria, and this is all in the documentation. The other issue that is a bummer about filtering is that you can only filter by one type of variable at a time. So if I want to look up all the binary classification models that were created after a certain point in time, or that came from a certain data source, I can't do that in one call. I have to iterate over the models and do secondary filtering myself. You also, unfortunately, cannot filter by tags, as we saw there. A third obstacle is that a lot of the operations in AML are asynchronous, and you can deal with that either by using an SDK and some of its niceties like the wait functionality that Bodo provides, or you can poll yourself. And then finally, some evaluation data is not available via the API. However, I believe that the flexibility and the replicability of managing your models via the API are worth these trade-offs. There are two main ways to incorporate new data into your existing AML model. Both of them rely on the fact that you can point a data source to a directory on S3 instead of to a file. So we have a directory here, adult income/data. We're going to upload a new set of data to this directory or this prefix on S3, and then we're going to run a script to create a new model based on the data. You may recall in the loading your data module that we grabbed the data from that open source data repository and pulled it down and processed it and turned it into 3 different files. And so we had one training file, one file we used for a batch evaluation, and then we had one extra training file we held off on. We're going to use that training file now. So we upload the training file. Let's take a look at the script, which will let us create an additional model based on the new data. So we have a couple of helper functions, including one that looks up the AUC for the binary classification system we're going to build. The AUC is a score you can use to compare 2 different binary classification systems. Basically, it is an indication of how closely the model conforms to reality. Closer to 1 the AUC is, the better it does. So we're going to use that to compare and contrast our 2 models that we're building. We also have our bucket name and on line 28, our data location. That's the same as the location that we uploaded the new data to. And we also have a schema. That schema is in your working files as well as this Python script. It is nothing new. It has a target attribute name, but we've seen the schema throughout our model exploration of this data set. We create some data source variables, and then on lines 45 to 66, we create the data sources. On line 53, we compute statistics, which you need to do for anything you're going to be training a model on. On line 64, we do not have to compute statistics because this is an evaluation. We wait for these data sources to be available, and then we are going to look up our old model. And if you'll recall in the Managing via API chapter, we tagged our current production model with that environment tag, prod-income. And that would allow clients to use that model by looking up the tag versus looking up a model ID or a model name. We're going to end up moving that tag to our new system. We are going to, on lines 76 through 79, get everything about that old model, including the recipe, because all we're doing here is incorporating new data into our model. We're not changing the recipe. We're not changing any of the training parameters. We're just incorporating new data. On lines 89 through 96, we are actually creating the model. We hard code the name on line 91, but you could imagine that we could change that and have that be parameterized as well. We wait for the model to be finished, and then we are actually going to do an evaluation against this model, because that's going to give us the data we need to determine, do we want to move forward with this model or do we not want to? Then wait for the evaluation to be done. We retrieve both of the AUCs, we print those out, and then this is where you'd probably want a human being to intervene or at least do some kind of comparison between the AUCs. Since this is a class, we're not actually going to do that. We're just going to move the tags from the old model to the new model. And again, we can do all this via the API. So on lines 140 through 153, we update the new model with the tags. And remember that on line 143 and 144, that is the tag that our machine learning clients are using to find the right model. And line 147 to 148 is a tag that is going to help us identify which batch predictions and which evaluations were done off of this model. And finally, we remove the environment tag from the existing model. You could also give it a different value, prod-old-income or something like that. So let's look at the output. So you can see that we created the data source, created the model. We have our old AUC and our new one, and our new one is higher. So we are going to move that production tag from the existing model to the new model. This was one way to incorporate new data into a machine learning environment. You are not updating a model, but you're creating a new model with all of the same settings and new data. So it's essentially the same as an updated model. There are two ways to incorporate new data into your AML system. Models, of course, are immutable, but you can create new models based on the same data or a superset of that data. We're going to see how to do that via the AWS console. So we have a data source that is pointing to a S3 directory instead of an S3 file or an S3 object as we had previously. So we can see we have one file and it totals 2.3 megabytes. This is the directory that we're pointing to. We are going to be able to upload another file that has the same schema. Once that file is uploaded, we can look back here. And so when we create a model off of a data source and we use the default settings, we actually end up creating two subsidiary data sources that take a portion of the existing data source records and use some for training and some for evaluation. When we go to this data source, we can see we have one file, and if we use the data source to train an ML model, and again, we're going to use the defaults just as we did for the previous ongoing model, we are now going to see some new data sources created. And if we look at these data sources, we will see that they incorporate the two CSV files for a larger number of records. So if we add 3 or 4, every time we create a new model off of that root data source that pointed to the directory, we're going to see new subsidiary data sources created, and the models that are built off of those data sources will incorporate the new data. That is one way to incorporate new data into an existing model. Create a data source, point it to an S3 directory and not an S3 object, and create new models off of that data source as you add or remove data. So obviously there are other use cases for Amazon machine learning other than the income classification system that we have gone over in this course. Basically, any place you have good data and want to make predictions about the future, Amazon machine learning can be a fit for. Some common use cases might be looking at a sales lead and seeing how likely they are to close, looking at the prices of something, a commodity or a home or a car, and estimating based on previous data what the value of that car is, looking at customer churn and trying to see patterns of customers who've left and other customers who look like they're about to leave so you can reach out to them before they do. Even something as different as looking at a catalog of parts and seeing the attributes of parts that have failed and seeing whether there are any patterns in those parts that indicate that there may be other parts that are about to fail. I have written 2 scripts that will process data from a external open data set and put it into a format that you can use in Amazon machine learning. The Python scripts are part of the working files for this section, and inside the Python scripts is the URL where you can download the data. So it gives you a little bit of real world experience in finding a data set and bringing it into Amazon machine learning. One of these is a data set around housing prices. So it is going to let you predict the house price for a given observation, a very limited data set. And that is a numeric target value. The house price is a continuous variable. The other model is a wine quality data set, and that is a categorical target variable. And both of these can give you experience building things in Amazon machine learning. It also will let you explore the difference in the evaluation screen that I mentioned, where numeric target variables have a different looking evaluation screen because you're looking at the residuals as opposed to in a binary classification system looking at the UAC. If you're going to use the wine dataset, make sure that you set the target variable in the schema as a categorical value because since it is only numbers, Amazon machine learning looks at that and thinks it's a numeric value. So Amazon machine learning is not perfect for every situation where you might want to use machine learning. There are definitely some limitations. First, and possibly most important limitation is that the models that are created by Amazon machine learning are read-only. That means if you have new data that you want to incorporate in your model, you have to train a new model. For example, if you had a model built on a year of sales data and another 6 months pass by, and you want to incorporate that last 6 months of data, you would have to build an entirely new model. This means that if you're going to be incorporating new data regularly, you should automate an evaluation of your models. Luckily, Amazon makes it very easy to do so. Another limitation is that AML only supports structured text data. That means that if you want to build machine learning algorithms to handle images or sound or video, then you need to find some way to render that as text. Now, there is some support for unstructured text data. There are a couple of transformations that you can add to your recipes to take text strings and turn them into multiple feature sets. There's the n-gram transformation and the orthogonal sparse bigram transformation. But in general, you're going to be taking structured CSV files that consist of numbers, text, and Boolean values and turning them into a model. You also have no insight into your model. You don't know the underlying equations or anything past what Amazon tells you in terms of the algorithms that are used. You also have some limits on the number of variables you can have. Amazon has a concept of soft limits and hard limits, and soft limits can be raised by opening a request with Amazon. The number of variables has a soft limit of 1,000. So if you have more than 1,000 features in your data, you are going to need to ask Amazon to increase the number of variables allowed in your account. There are a number of other soft and hard limits with Amazon. The number of different kinds of values you can have in a given category is limited to 100. That's a soft limit. You can, as with other soft limits, raise that with a request. However, increasing that will also increase the risk of failures when you are doing batch predictions or training the model and could lead to poor performance. There are some other limits, such as a 7-day runtime and 25 simultaneous jobs at once. And then the documentation actually has a really good list of what the limits are. It's important to note that Amazon doesn't do a great job of telling us what the soft limits are and what the hard limits are. And the simplest way to find out if something is a hard limit or a soft limit is to ask a specific question in the Amazon forums or open a support ticket. And so if you are planning to build a model and you review the limit documentation and you know that you're going to bump into a limit before you even start with Amazon machine learning, open a support ticket with the Amazon folks and ask about that particular issue. Another limitation of AML is your limits in terms of being able to customize your model. You have a limited number of knobs you can tweak to build your model. These include things like the learning rate, the model size that you want to end up with, the number of passes over your data that you want to make, and regularization parameters, which basically penalize extreme weight values. So if you have values that are very, very small, one kind of regularization parameter will push that to 0, and there's another kind of regularization parameter as well. In general, if you need to control all of the parameters of your model, Amazon machine learning is probably not a fit for you because it's not going to let you do that. Another limit that could be very important to you is the lack of an ability to export your model. You may want to export your model and run it on a different set of hardware or share it with somebody else, and that simply is not possible with AML. There's no import nor export of models. It's a black box. However, you absolutely can share your model and you can let other people use it, but you just cannot export it and take it and run it someplace else on a different piece of hardware. We've just gone over some limits of Amazon machine learning. These limits point to a number of situations in which choosing Amazon machine learning would be a poor choice. If your data is not text and cannot easily be represented as text, AML is not the right answer. If you need a model to be updated very regularly, especially if you're not willing to invest in some automation, AML may be a poor choice. If you need high-level and low-level control of your model, if you need to share your model, and not just access to your model, which can easily be shared, but actually share innards of your model, the weights of the variables that determine the predictions, you don't have access to that, and you certainly cannot share that. So in this module, you've learned some of the limitations of Amazon machine learning and where it may not be the appropriate tool to solve your problems. So now we're going to look at some alternatives to Amazon machine learning. Amazon machine learning is good for a certain set of problems. Problems that have supervised learning problems where you have a set of data that has observations and target variables, and you want to predict the target variable from observations in the future. The data must be text, and you can have tremendous amounts of text data, but it has to be structured data in CSV format. You can process up to 1 terabyte of observations at a time, and you can train on up to 100 gigs of data, but it all has to be text data. You also might be interested in the fact that you have no infrastructure to run when you are using AML. That means no infrastructure to run if you want to do batch processes, or if you actually want to have a web API that your clients can call into. You also get, with IAM, fine-grained control over who can do what to which model, including whether they can create new predictions, create just real-time predictions, or create an entire ML model environment. And you have to be comfortable with the limited tweakability of the AML model, the fact that you can't export it, the fact that you only get to choose one algorithm and limited training parameters. If Amazon machine learning does not work for you, if that previous slide does not describe your problem, you have some alternatives. There are solutions within the AWS environment. Point solutions are good for a specific type of problem. This includes things like image recognition, which the Recognition service provides, and speech recognition, which Amazon Lex provides. There are other general solutions. These might be AMIs. There is an AMI maintained by Amazon, which is called the Deep Learning AMI, which contains a wide set of open source and machine learning tools pre-installed. There are also solutions in the AWS Marketplace. If you're looking to work on really, really large data, terabytes and petabytes of data, you can also leverage Spark, which is a big data framework that also has machine learning tools and runs on the Elastic MapReduce service, which is AWS's Hadoop in the cloud solution. If you're looking for solutions outside of AWS, you can choose again between hosted solutions that you don't have to run infrastructure for and self-managed solutions. Google Cloud Machine Learning Engine and Azure Machine Learning are two hosted solution options. And scikit-learn, which is an open source Python framework, has a lot of flexibility and a lot of examples out there on the internet. The URLs for all these alternatives are in the working files for this chapter. And these are some of the alternatives to AWS machine learning. This course is done. Thank you very much for your time. In this course, we've talked about machine learning in general and how Amazon machine learning is a specific subset of machine learning. We've created an Amazon machine learning system from scratch. We've taken raw data from that publicly accessible data set, created IAM users, created a data source, created a model, talked about the attributes of that model, create evaluations to determine how that model maps to the real world, and then create predictions. At the end of the day, we're trying to turn raw data into patterns that we can make predictions against. We also talked about some advanced concepts around tagging, managing your models, updating your model. And then we also talked about where Amazon machine learning is appropriate and where it might not be. Next steps include exploring on your own, finding some additional public data sets. I mentioned some in the additional use cases module. And more important than other data sets that are in the public are your data. And I think using your data has two benefits. I think using your own data has three benefits. One is you're a domain expert. A second is that you can actually provide business value by looking at your data and trying to make predictions against your data. The third is you're going to gain an intuition for building models. Using your own data is going to be far messier than the data set that we used, which was a public data set that was, in some sense, groomed for machine learning. Your own data, you're going to have to learn a lot more about what variables you can drop, what variables you need to tweak, what transformations you need to have. It's going to be messy. You're going to have a lot of chance to experiment to find the best model for you. The AWS documentation is also a great place to go. It is fantastic.